Okay, 9.6. This is the last part of chapter 9, the last unit. I'm going to start down here on the vocab. And we're going to focus on this word here, inverse. The word inverse is somewhat like taking the opposite. It's somewhat like the opposite. Back in algebra, we'd have an equation like this, right? X minus 12 is equal to 16. You'd have to solve for x. And to solve for x, we'd actually take the inverse of this side, okay? The inverse. Negative 12 plus 12. It's like the opposite to solve for this equation. Okay? And that's what we're going to be working with today. We're going to be working with the inverse of all our sine, cosine, and tangent. Okay? I'm going to start by writing this right triangle here. It's a nice right triangle. We'll call this angle A, this B, and this C. Okay? And I want to write up here, so, toa. Okay, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, I'm going to label these sides. I'm just going to make a nice 3, 4, 5 right triangle. Okay? I'm going to start with the tangent because that's our first vocab word, inverse tangent. Okay, and I want to find the tangent of A. How do I find the tangent of A? Well, the tangent of A is equal to opposite, which is 4, over adjacent, which is 3. Okay? To find the inverse tangent of A, okay, we want to find the inverse tangent. We actually, we want to just solve for A, right? We want to solve for A, so we want to get that tangent out of there. So we multiply by the tangent inverse. Okay, it looks like this on both sides. The tangent inverse. Okay. On my calculator, it looks a little different for each of yours. Right here. Oh, I'm moving my calculator. Right here, I just put my mouse. There is the sine inverse. It's in blue, the cosine inverse, and the tangent inverse. They're all in blue. They're right above sine, cosine, and tangent. Okay? If I multiply this by the tangent inverse, this tangent inverse will get rid of tangent. Okay? It's just like if we had x minus 5 equals 10. Okay, that plus 5, that would cancel out our 5. So that's what that tangent inverse does. Okay? Whatever we do to one side, we do to the other. So, if I found the tangent inverse of 4 over 3, we'd get 53.13. Okay? Now what do we just solve? 53.13. We just solved for angle A. 51.13. That's what angle A is. It's in degrees. Now, I have to make sure that's in degrees. Okay, again, I have to go into mode and to make sure that that is in degree. If it was in radian, I would be wrong on my answer. Okay? The inverse sine. Well, if I want to find the sine of H, okay, well, the sine of H, we'll do this one in blue here. The sine of A is equal to opposite over hypotenuse, right? So 4 over 5. And I want to take the inverse sine. The sine of inverse, sine inverse. Just an example of what that inverse sine looks like, okay, or inverse cosine, inverse tangent, whatever it may be. If I took the sine inverse and of the sine of 10. Okay, those sine inverse and sine should cancel out. We should end up with 10 here. That's what we do. Those just cancel out. We end up with 10. Okay? Which gets me to right here. Sine inverse and sine. We're left with A is equal to, now if we did this right, we should get the same answer. The sine inverse of A is 4 over 5. We should get 53.13, which is what we had up here. I didn't write this correctly. 53.13. Okay, we got the same answer. Right? And inverse cosine is the exact same thing. Just with cosine. Solve a right triangle. We are solving for every piece. Solve for all. We're finding missing angles, missing side lengths. We're solving it all today. Okay? Down here, using these trigonomic ratios. Let A be an acute right angle. The inverse tangents. If tangent of A is equal to x, then the tangent inverse of that would be our measure of angle A, which is what we were doing earlier, which is what I just proved. Okay. Let's get into our first example. Determine which of these two acute angles has a given trigonomic ratio. The cosine of the angle is 24 over 25. Okay. Well, remember, what's cosine? So, it's adjacent over hypotenuse. Okay, well, if I started with G, I'd look at adjacent, which is 7, over hypotenuse. So the cosine of G is equal to 24, or sorry, I messed up. Adjacent over hypotenuse, 7 over 25. Cosine of G is equal to 7 over 25. Okay. The sine of G, I just want to point this out. The sine of G is opposite over hypotenuse, so 24 over 25. Okay. The cosine of F is the same as the sine of G. So the cosine of F is equal to 24 over 25. So that would be our answer, the cosine of F. Number 2, the sine of the angle is about 0.38. Okay, so now we're working with sine. Remember, sine. Sine is so. Opposite over hypotenuse. Okay, so if I start with E, the sine of E is equal to opposite, which is the square root of 2, over the hypotenuse, square root of 14. Okay. The sine of F is equal to the square 2 square root of 3 over the square root of 14. So we have to find out which one is 0.38. The sine of E, we can also write it as the square root of 1 over 7. Okay, so let's find this out. Let's find the sine of 1 over 7 is equal to, square root. Sine square root of 1 divided by 7 is equal to 0.006. Let's find the sine of F is the square root of 2. Oh, I'm sorry. We're just looking for messed up, guys. My apologies. Okay. We're just looking for the sign, so we're just typing in those fractions. That's my apologies. Which is square root of 1 over 7 is 0.377, which is about 0.38. So the sine of E. That is our final answer. That's my mistake. Okay. We're just looking for just typing in those fractions, opposite over hypotenuse, to see which one is 0.38. Down here, let H be an acute angle. Use a calculator to approximate the measure of angle H to the nearest 10th degree. We have sine of H equals 0.2. Yeah? We want to find the actual measure of H. So we have to get rid of the sine of H. The sine. We have to get rid of sine. How do we get rid of sine? Well, we multiply this side by the sine inverse. We multiply this side by the sine inverse. Okay, our signs cancel. We're left with H is equal to, we have to type this into our calculator, 0.2, or sorry, the sine, inverse sine of 0.2 equals 11.5. So H is equal to 11.5 degrees. Number 4, the tangent of H equals 1. So we want to take the inverse tangent, both sides. Okay, so tan inverse tangent of 1 should get us 45. So H is equal to 45 degrees. Okay, and the same goes on for each of those problems, 4, 5, and 6. Down here, solve the right triangle. We are solving for each piece of the triangle. For 7 and 8, we have a missing side length that we can easily find. How can we easily find it? The Pythagorean theorem. Okay, we know that 6 squared plus 12 squared is going to be equal to, call this x, x squared. Use a different color, make it easier to see. Okay, we're going to type this into a calculator. We have 36 plus 144. That's equal to 180. The square root of 180 is 13.4. So x is equal to 13.4. Okay. Now, I have to find my missing angles. Angle A and angle C. I really only have to do math using the sine, cosine, or tangent to find one of these angles, and then I can just subtract what I find minus the 90 from 180, and I have my other angle. Okay, so you choose either A or C. Which one do you like to choose? I'm going to choose A. I'm going to choose A, and you can either work with sine, cosine, or tangent. Again, all is fair. All is fair here. I'm going to say the tangent of A is equal to opposite over adjacent, 12 over 6. Okay, and I'm not working with any decimals at all. Okay, so the tangent of A is equal to 12 over 6. How do I get rid of that tangent? Multiply by the tangent inverse. So I'm left with A is equal to tangent inverse of 2 is equal to 63.4 degrees. So A is equal to 63.4 degrees. And now what's C? Well, I can just take my calculator and I can say, hey, 180 minus the 90 degrees that's already given to me, minus what I just found, 63.4, will give me that missing angle, 26.6 degrees. So C is equal to 26.6 degrees. And I solved it. I solved my triangle. I know every part of that triangle now. On to number 8. If I want to find this side here, then we're going to do the same process. We know that 21 squared plus x squared is equal to my hypotenuse squared. So again, if I just take my calculator, I take 75 squared, I'm going to get 5,625, and I subtract 21 squared. Okay, I get 5,184. Then I would take the square root of that number, and I get 72. So x is equal to 72. Now I want to find my missing angles. And I want to find C and D. You choose which one you want. And I'm going to take the sine. This time I'm going to take the sine opposite over hypotenuse. Sine of C is equal to 72 over 75. And again, I need to take the inverse sine. That'll cancel out here. Inverse sine. So the inverse sine of 72 divided by 75 is equal to 73.8. Now, I want to find D. I'm just going to take 180. I got to move my calculator here. There we go. 180 minus 90 minus 73.8, and I get my angle D, 16.2. In your note or in your homework, I should have been a little bit more specific. Okay, if we had to find ED, right, or if we had to solve this triangle, here's how we'd write our final answer. ED equals 72. Angle C equals 73.8 degrees, and angle D is equal to 16.2 degrees. Down here for 9 and 10. 9 and 10. We can find the missing angle. We can find this missing angle. How? What's 180 minus 90? It's 90 minus another 52. We get, what, 38? Angle N is 38 degrees. Okay, so my final answer over here, I know that angle N is equal to 38 degrees. And now I find my missing side lengths. The missing side lengths. From 52, I'm just going to label that x. I can say the sine of 52 is opposite, so sine of 52 is equal to x over my hypotenuse, 3. Okay, now how do I solve for x? Multiply by 3 on both sides. So 3 times the sine of 52, I get 2.4. So x, or mn, my final answer, is equal to, what did I say, 2.4? 2.4. Now, you can do the same thing, or you can use the Pythagorean theorem. Okay, you can say, we'll call this x over here. We'll call that y. We can say the sine of n is y over 3. So sine of 38 is equal to y over 3. So 3 times the sine of 38 is equal to 1.8. So my final answer, Lm is equal to 1.8. Yes. Okay. Good. So we solved each piece of our triangle. Number 10, I'll leave up for you guys. Number 11. Oh, which one am I? Yeah. Number 11. A boat is pulled in by a winch on a dock 12 feet above the deck of the boat. When the winch is fully extended to 25 feet, what is the angle of elevation from the boat to the winch? Okay, so we're looking for this angle here. Okay, so we're looking for that angle. We'll call that angle x. Okay, so the sine of x, why do I use sine? Because we're working with opposite over hypotenuse. It's equal to 12 over 25. Okay, so sine of x is equal to 12 over 25. How do we get rid of sine? We just want to solve for x here. You have to take the sine inverse. That gets rid of that. We are left with x is equal to sine inverse of, I need my fractions, 12 over 25. We get 28.7 degrees.